And now, Felipe Hoffa, developer advocate at Google. What we know, what is happening, and what we are made of exploring big data on the cloud.
Okay, now you can hear me, but we're missing the slides. We're connected here. Let me see if I need to displace. I don't see mirroring. Is this connected? Should we connect and disconnect? Oh. That made something happen. Yes, we are on. And let me put this here. Hello everyone, long day today. Thank you for staying until the last talk. It's hot, it's warm. And hello everyone watching the live streaming, 5 million people, I don't know. My name is Felipe Hoffa. I come from Chile, but I live in San Francisco now. I work for Google. I have a t-shirt. Let me take off this. Oh, it will be hard. I work for Google. I don't know who here is using Google Cloud. No one is using Google Cloud? Yes, I see some hands. We talked. Have you tried BigQuery? BigQuery? Yes? No? No? Yes? Okay, so not a lot of people here know about BigQuery, and I will gladly introduce you to it. The time is changing here. The big question here, the topic I want to touch today is how to explore big data on the cloud. Some of you have been working with big data. Yes. We all have problems when using big data. Who knows SQL? Yes, everyone knows SQL. Who has queries that run for more than a minute, hours, days? Yes, everyone. So if we can reduce that, it would be a very nice thing. But let's get into the data revolution. We're talking about big data. We're talking about big data now. We didn't 15 years ago. This is a new thing. But it's not that we have more data now. We've always had data. The difference is that now we don't need to delete it. We can keep it. And there are 3 big steps to get this. One is price. Once the price of storing data goes down, you don't need to delete it anymore because you can get more value from storing it than the cost. 15 years ago, this was the reality. When I started using computers, storing 10 megabytes was $3,500, and that was considered cheap. That has changed a lot. Access to data. This started changing a lot once Tim Berners-Lee stood before everyone, considered his first goal in life done. We have the web, everything is open, we can access anything we want to learn, but now he's asking for people to share raw data. We need the ability to analyze by ourselves whatever someone else is saying, and since he stood there, people have been opening data. We've got open data portal for government, cities, and people are sharing raw data, and that's beautiful. And another variable, very important, is speed. We have data stored, we have data shared, but if it takes hours to download data, it's not good. We've all been there. If it takes days to get results, we submit a query, the query comes back days later. Things can be better than that, and they are improving a lot, and we have seen a lot about that. What is happening at Google about this? Everyone knows Google? Yes, kind of. Well, this all started a long time ago. We have an open web. We have a lot of different web search companies. Everyone thought search is solved. We can do better. But Google collected all this data, open data, because anyone could collect it. And instead of looking at the different pages, the content of the pages, we started looking at the links between them. So basically, it took a new step, creating PageRank, to be able to take the same open data, analyze it, collect it all, and create the technology to apply algorithms. The basic idea here behind open data and what we can do with it. You need ideas, you need data, and you need the technology. Google proceeded to invent a lot of the technology that most or all the basic stones for what we are doing today, starting with the Google File System, MapReduce, Bigtable, etc., etc. That's where Hadoop comes from and other projects. And well, a month ago, we opened up Bigtable as a service. If you're using HBase or Cassandra, moving to Google and using Bigtable as a service might make your life simpler. Anyone on HBase, Cassandra here? A little bit. Yeah, it's a complex life. If you can make it easier, if you can make it faster, things work better. Or if how we also have made available Dataflow, our product that combines the best of Flume and Millwheel. Flume is it's a way to optimize your map reducers. It takes care of making things simpler for you, as Millwheel is the best way we have to process streaming data. And using those services, you can make your life simpler, easier, faster. And these ideas are also, for example, if you write your data for the data flow SDK, you can choose to run things on Google or on Spark or on, I just forgot the name, Apache Flink. But today I want to focus on this paper, Dremel, and the product we made available on it using Dremel BigQuery. This is available for everyone on the cloud. Processes terabytes in seconds. It's fast. It uses SQL. It takes no capital expenditures. You just pay per query and for storage. Forget about servers, turning them on, turning them off, indexing. It connects through an API to wherever you're using R, Tableau, Pandas, etc. And you can run queries for free every month. So everything I'm going to do here with open data, you can do it by yourself for free and just try out if things are fast and you can get new insights. So I have examples, I have other videos from startups, what they are doing. Today I'm going to focus on open data. A little bit about streaming. These guys created an open source package to make streaming to BigQuery easier. BigQuery can accept up to 100,000 records, rows per second of live streaming. And they, for example, are working with Elasticsearch for their live queries while storing everything on BigQuery to be able to analyze all the data they have. I also wanted to showcase my Romanian hero, Kodok, Martin Kodok. He presented at DevTalks in Cluj 2 weeks ago. And he's my hero. So whenever you have questions about BigQuery, you can go to Stack Overflow. I'm there replying it. Jordan Tigani is the top answerer. But you will find Martin every day answering questions. He has like 80,000 Stack Overflow points. He's really doing a beautiful job. If you're in Romania and you can contact him and you need help, he will probably there. And look at his talk about complex real-time event analytics using BigQuery. But let's get into open data. As I was telling you, price is a big step. BigQuery is reducing price every 3-4 months. This is storage on BigQuery that has gone from $120 per terabyte to $5 per terabyte a month. So you can store open data there and share it with others. Speed is super fast. Let me show you the first example I have. Live queries. Anyone knows how many page views Wikipedia has in a month? Any guess? 4 million? 4 million page views? More than that. Any guess? 50 million? More than that. 1 billion? Maybe. Let me query it. I have this stored on BigQuery. I have this table, for example, with everything from June 2015. It's a table, 5 columns. Each page, basically we have for each page the title, in which language, at a certain hour, how many page views this page got, their number of requests. I'm not sure if you can see this. But as you can see, it's not raw data, as they are publishing only the aggregated numbers for each hour for each page. And I took this data from the web, I loaded it into BigQuery. It's almost 6 billion rows of data in 380 gigabytes of data. And to get the number of requests, I just need to write a simple SQL, sum the number of requests. The only problem here is that we are going over 5 billion rows, but it works pretty fast. It has 20 billion rows. This is fast, unless I have this number pre-computed. It's much harder if I had to analyze all of it. So let's run some regular expressions here. Just to make sure I haven't prepared anything, can you give me any random word? Which one? Obama. Okay, let's see the pages that match anything that starts with an O and has an A. It might be anything, probably Obama. But I'm running a regular expression over 5 billion rows, and again, it's fast. If you want to know what are the pages, we just add the title here, we order by the first column in descending order. Let's get the top 20. And if this is fast, it takes 2 seconds. Yes, Barack Obama is the first one, but the second one is Osama bin Laden. And you just can start exploring things, and I don't know if you're laughing about the result or how fast it is, but it's fast. And with Wikipedia, you can see what is happening, what people are interested in. Just to show you how to load the Wikipedia web pages, Wikipedia page counts. You can find the numbers using Google. Wikimedia projects, 2015, June. Today is June 11th at 12 p.m. UTC. That's the latest published hour by hour data from Wikipedia, and I can just download this file into my cloud server, so I don't depend on Wi-Fi. This is basically, what time is right now in UTC? Time in UTC. You know the UTC time? Yes, it's 3 p.m. They are 3 hours behind, but it's the latest data. And I can run something like this. I'm going from 2015 at 12, 2015 at 12. With a command like this, I can load compressed data into BigQuery. I'm telling it to take this file, put it on this table that has these 4 columns, 2 are integers, and it's a special kind of CSV. It uses spaces and no quotes. Let me put, okay, taking a little bit to download. It's not my fault, but while it downloads, I can show you how, what's the magic behind BigQuery, how is it so fast. First thing, we don't care about data locality. That's not a problem in this system. You can just load your data into BigQuery. It gets into distributed storage, columnar format. And whenever you write a query like this, a big number of computers start loading it in parallel. How many computers? It only depends on how much data you have. So processing 100 billion rows or 1 trillion rows, depend up to certain limits, should be as fast as the other, because we are doing this in parallel. All these servers read the data in parallel, throw out wherever they have to throw out, and they start sending the data up into the tree of servers, reducing it until we get the final result out. If you have more questions about it, ask me later. I'm happy to come back. But let me see if I can load this into BigQuery. I have it here, June 11th at 12. And let's leave this loading. So open data on BigQuery, just to show you some beautiful samples I love working with. Genomics. Turns out you can use SQL not only for logs and analyzing business data. As you might know, our DNA is just a very long string of 4 characters. You can put this in tables. You can work with genes. There are at least 3 projects that publish open genes that I've been working with. This one I have the PGP. It's 170 people, 400 gigabytes of data. And you can go in and explore this data. There is the Southern Genomes project with more than 1,000 people. And you can start writing queries just to show you some samples. People are the Cancer Genomics Institute is working with BigQuery and researching genomics. Autism is also a genomic, it has a genomics component that's being analyzed with this tool. A query lab. This query is going through our 1,000 people and count 1,000 people in this data set, and it's counting the number of variants they have in each position. If there are single variants versus double variants, and we get 2 columns for each person. We can visualize them, and it turns out people land in clusters. Somehow each person, if I look at your DNA and count the number of variants, you will land somewhere in this cluster. And the first question that you might ask is, how did someone end up, where would you end up? And what does it mean to be one of those 4 clusters? Any guess? How relatives? Yes, that's very close, because close people are close. Turns out if we turn on, sorry? Environment, kind of. Yes. So let me show you. I have here, I have colored them by their ethnicity. Do they come from Africa? Do they come from America? And yep, Africans are the ones with the higher variance. And if you take your genes, you can put them on your chart, see where you belong in this chart. It's pretty cool. And there's a lot more we can do, but let me jump to a completely different place, the whole world, what is happening around the world. This is the GDEL project. This is a professor in Washington that is collecting all the events that are happening in the world, from yesterday, from this morning, to the last 30 years. This is a query I ran last night to see what has been happening in Romania. I'm just counting the number of events in Romania for the last 30 years, and I got a chart like this. And it's pretty interesting that we're getting a lot more events now than before. It's mainly because now we have Google, we have the web, a lot more is being published. So this really doesn't help me see what happened in Romania. But I can normalize this, just dividing by the number of total events in each month. And I get a chart like this. And I can see the history of Romania, and I can see when important things that have happened that have captured the world's attention. December 1989, I've been learning this week about this. April 2008 was important too. I'm not going to teach you about Romanian history. I would love to learn it from you. But I can show you my country's history, Chile. This is the timeline. I just decided to highlight 3 points in case you've heard about Chilean history and what kind of things might be showing up here. Any guess? Any important Chilean things? We had, for example, a guy called Pinochet as president for 17 years. And the day the country voted to have him out of the government was October 98. Or in March 2010, we had a big earthquake. Later on 2010, everyone was paying attention to the Chilean miners, if you heard about them. They show up here, and you can dig into the news, important news, news about different aspects, and you can just come here. All this data is released for free, and you can see what is happening around you, map it, etc. Let me get into the next topic, because there's a lot to see. Weather data. You might know what happened in your business yesterday, last week, what you sold, what you were selling. If you have a a mobile application, you might know how people are using it and where. We have location data. But how can we know if it's related to weather? Do people use your application more when it's hot, when it's raining? Do you know each day that rained last year? I know. This is my query for Bucharest. And in few seconds, I can see wherever in Romania I want what was the minimum temperature, the maximum, when did it rain? It turns out it rained a lot yesterday. So it's not, according to this, it's not weird to get rain in June. That we can see a lot of rain there. And it allows me to see for any city, place in the world, what is happening, correlated with my data, etc. Freebase. Freebase is a collection of knowledge. Everyone knows Wikipedia. Anyone knows Freebase? Freebase takes Wikipedian data from other sources and converts it in a knowledge graph, an RDF graph, triples. It's basically composed of facts, more than 2 billion facts, like Romania has this many citizens, this person is a man or a woman, this person is a professor, etc., etc., etc. You have 2 billion facts that you can use to understand the knowledge we have in a structured way. Recently, Freebase got deprecated, or to say this, we announced that we are merging it with Wikidata. Next month, I'm going to the Wikipedia conference to learn more about how Wikidata is absorbing all these facts. But I'm going to present this sample with Freebase data. Here I have a query that looks at the age of everyone that is on Wikipedia. So if you want to be on Wikipedia, what's the most popular age? Turns out the peak is here at 26-year-old. Those are most of the famous people on Wikipedia. So that's the peak. We have a different peak here for the baby boomers. And you can go and analyze this in what further divide it in any dimension you want. Male versus female, professions, locations, where they were born, how old they are. In this case, I had another talk with my friend Eva, where we went to see the gender gap. Are there more women or men on Wikipedia? And what are their professions? And at the end of this talk, we wanted to write a query to find the most popular woman, to find the most popular woman for each country in the world. Now, how would you do that? You have all the knowledge about who is on Wikipedia, what do they do, but how do you look at popularity on a knowledge graph? Sorry? I have the page views. I know how many page views each one is getting. So with a query like this, I can do a join. BigQuery has no problem with big joins. I can join my page views with my knowledge, and I can ask, in this case, this query is asking for everyone that has this gender, female. That's how things are encoded in Freebase. I can look for a key that will allow me to join it with Wikipedia. I'm transforming the key in real time. I'm doing a regular expression replacement to take out the Wikipedia ID part. And then I can just join it with my page views. Just to make it a little more interesting, I'm taking the place of birth for everyone. I'm transforming the place of birth, that might be a city, and transforming it into the country. I'm doing this join, I'm ranking the results and getting the top one for each country. So let's see if this query will run. And just to make it more interesting, maybe I will be able to run it with the last hour Wikipedia page views, if I was able to load them while I was talking. So, yep, they loaded here. I have my query, so instead of looking at 2014, I want to look at 2015, June 11th at 12 UTC, and run my query. This query goes through 60 gigabytes of data, looking at the facts, normalizing, ranking, and it ran in 9 seconds. That is cool. And it turns out the person that has the most page views right now, the woman with the most page views, He was born in the USA. Bryce Dallas. Do you know who her is? I'm scared of searching, but it's an American film actress that somehow it's in the news right now, and people are searching about her. But I have data for the whole world. I can download this as a CSV, my results that I just got. I can show in Finder. My CSV is here, open with text edit, just to look at the results. And as this is geo-referentiated data, I can put it on a map. This map was written by my friend Eva Gasperovich. So I can paste the data here, and I get a map of who is getting the most page views during this last hour. I don't know if the results make sense to you, but you have a... Yes. These are the results from this last hour. They change hour per hour. You can go in, write the same query, ingest, visualize, do whatever you want. I like that you look happy like watching them. And yep, this is how we can use open data, understand the world, take wherever we can find. Every day we have more interesting data sets. And just to come back to the first concept, the 3-step for the big data revolution is price. They keep going down, storing data, analyzing data. Speed, you can see how fast it is to do it right while I'm talking here. And access, this is where we can all work and ask the governments to publish data, to put it on the right platform, and share what we have and use it. Thank you very much. Felipe Hoffa, follow me on Twitter, Stack Overflow, blah, blah, blah. Thank you. Yay.
Thank you.
Oh, and if you have feedback for me, please give me feedback. If you like the talk, you can go there, and if you don't like it, please tell me why. I love learning more.
Thanks very much. Question. Please.
You have a question prepared.
Yeah. It's working, I think, right? You just mentioned something about the base, and you mentioned something about an RDF graph. I'm just wondering, what are you using for interrogating that graph? Because basically, when you are building the graphs using the RDF, you are using Sparkle for doing these kind of things, right?
Sorry.
I'm just wondering, what are you using there for doing?
Yes. Wondering what you're using, what I'm using for the knowledge graph for?
Yes, for interrogation. Because basically, in the RDF graphs, you are using as a language.
Yes.
You are using Sparkle, right?
Yes. So the question is.
The question is, what are you using there for getting that time for interrogating the stuff? Because usually the Sparkle is running inside of the reasoners. So reasoners are time-consuming and resources consuming. So I'm just curious, what is the mechanism behind? Maybe you can give me some high-level description about it.
Yes. So the question is how I'm querying the knowledge graph with SQL. Yeah, we all know, well, if you know Spark SQL, it's beautiful, it's a great way to interrogate a graph. I'm just using normal SQL. It makes my life harder. It's harder to go through a graph with SQL, but it ends up working, especially when I want to query aggregated data. SparkQL is very good to get it for getting me for moving through the graph, but BigQuery helps me a lot when I just want to query aggregated data, and especially if I want to join this data with any other data set that I might have. In the example, page views. But let's say I have country data, just extracting population or extracting, I don't know, countries' religions to compare my results versus religion versus. I do it this way, just doing a lot of joins. And to make my life easier, sometimes I extract from the graph just the important relationships. For example, I have this table that has only the places of birth that I wanted to extract. So now instead of going through the full graph, I just go over those facts. I don't know if I mentioned it earlier, but one of the advantages of BigQuery is that has no indexes. I don't need to index anything. It just does a full table scan, full column scans for the columns you mentioned. So what you have here is a way to quickly go through the full data set. And if you know that you don't need the full data set, you can just partition it into smaller tables. I don't know if that answers the question, but hopefully it does. I can share with you all the queries I've written. Thanks.
When you loaded the data, you used some sort of, I don't know, script. What other methods are there for loading the data? And can you load it on a sort of a streaming basis?
Yes, so the question is how can we load data on BigQuery? In this case, I just took a gzip from the internet and loaded it directly into BigQuery. Normally with BigQuery, you want to load either CSV files or JSON files. You put them on Google Cloud Storage, and BigQuery can ingest them in a very fast time, and no index is needed. And you can also stream data, up to 100,000 rows per second. If you have live data coming in, it's immediately available for analysis. My favorite plugin to do this is the Rounds, the one that Rounds published. It's written on Go. So you use it as a middleman to just push records and retry if a retry is needed. Yeah, we have other ways. For example, if you have your flows over data flow, that will ingest data. If you have your data in Google Analytics Premium, any Google Analytics Premium user here, Premium will send your data, Google Analytics will send your data straight into BigQuery, so you can join analytics with BigQuery. Cloud logging, if you have logs, you can use Google Cloud Logging, and that will send all your logs straight to BigQuery in order for them to be analyzed. That answers, yes. So there are many ways to load. We have an API, and we have either batch or streaming data. Thanks.
Google expose a data pipe from this source to other application, client application?
How to pipeline this data from BigQuery to other places?
Client, yes.
Yes. So there are several ways. One is that you can export everything. If you have a big table and you want to export it, you can export it to CSV. If you want to analyze it with a map with several workers, BigQuery can optimize it, extract it to several folders, so every worker gets a fair share of data, fair amount of data. And yeah, or you can, or my favorite thing to do with BigQuery is just to extract extracts of data. So for example, if I'm doing machine learning, we did some analytics for, we predicted the World Cup results using BigQuery. We just took play-by-play data for every match during the World Cup and previous matches, and we extracted the best features we could as a summary to run logistic regression over it.